Hello, dear students, parents, and educators. Welcome to Math Inquiry Learning Journey by the GEM Foundation. In this session, we share simple ideas, activities which helps children make interesting observations by asking questions, thinking critically, becoming a bit more curious in their learning, and enjoy the process of learning. So we had three sessions of this mental division strategies, and this is the third session. In the first session, we had an idea about what actually division is and how the mental division strategy of dividing any number by powers of tens can be understood. And then in the second session, we kind of discussed an activity on how mental division of any number divided by multiples of 10 can be done and can be understood, which led to interesting observations as well. And in this episode, we are going to see on how these kind of learning actually helps children make their own simple, interesting conjectures, which are small ideas that form a hypothesis and then they test it and they find it to be working. But it all starts by asking some basic questions and leading to interesting observations and then checking out if it works for all numbers and then finally making it as a conjecture. Let's see what a grade 6 student has come up with through this process of inquiry based learning, which led the child kind of make out an interesting conjecture in division. Stay tuned. So it all started with a question of what happens if I divide a number ending with 5s repeatedly by 2? So when I asked her what prompted her to think about this, she was telling our example of 20 divided by 4 that I gave it as an activity, where we did explore and figured out that 20 can be divided by 2 and then again divided by 2. So she was thinking that, okay, why can't I divide a number ending with 5s for some reason and then divide by 2 repeatedly? Is there something that I can find off? So it started with this interesting wonder question and she pursued it. So with this question, I let the child to be on her own and then she kind of put this onto the table, onto the board and kind of figured out that okay, so I am repeatedly dividing 35 by 2, which I get 17.5. So I'm just going to write here, so 35 by 17.5, and then she divides 17.5 by 2 again and she got 8.75, and then 8.75 divided by 2 is 4.375, and again 4.375 divided by 2, so here she has, and that is 2.1875. So she keeps on dividing. And in our earlier discussions, I always encourage children to take different samples, to kind of take different numbers which they might think that gives them interesting observations. So then she was thinking that, okay, so in all these examples, I could see one interesting observation, and that is basically that all these numbers are ending with 7 5. So all these numbers are, the ending decimals are 7 5. So she was just thinking, okay, maybe then all numbers should end with 7 5, is it? So she started kind of working it out for different numbers like 25, 125. So instead of starting with 35, she started with 25 now. So 25 by 2 is 12.5, and then 12.5 divided by 2 is 6.25, and then 6.25 divided by 2 is 3.125. So here she has that, and I think somewhere she was also doing 3.125 divided by 2, which is 1. Yeah, here it is 3.125 divided by 2, which is 1.5625, and she also was going around like 1.625 divided by 2, which is some big number, decimal number here. So she kind of observed. In this case, oh yeah, there is also a pattern, but then here it is not 75 but 25. So then she kind of wanted to try with different numbers, like instead of 35 and 25, maybe taking 45 and 55 again. And then she found that with 45, all the numbers are having ending with the decimal numbers are 25, and with 55, the ending decimal numbers are 75. So this is a hypothesis that she has made that whenever I divide by 2, the numbers ending with 5, the categories are two. One, they have ending of 75, or the second one ending with 25. So now she has made a hypothesis. Hypothesis that these numbers, when they are divided by 2, they are either ending with 75 digits or they are ending with 25 as the digits. So now she started thinking on why it is so. Wanted to understand why behind it. So when she approached to me sharing this hypothesis along with some observations, she did not look for any answers. Instead, she was looking for some guiding questions. So I told her, when you have made such interesting observation of some numbers are ending with 75 and some numbers are ending with 25, can you make a list? Can you make a list of numbers which are ending as 75 and ending with 25? Can you see any pattern among the numbers and see how the pattern could actually result in this kind of an answer? Because in mathematics, there should be some relation and it should hold true for any number, being it as a small number or a very big number. If it works, then there should be some reasoning behind it. So I just gave her a simple question of, can you make a list of these set of numbers which ends with 75 and ends with 25, and do you see any relation or a pattern between those two sets? So she took the guiding question seriously and she came up with a astounding list that numbers ending with 75, 75 as the ending digits, right? So numbers ending 5 are 15, and then 30, and then 55, and then 75. So repeatedly, if you divide by 2, all these numbers end with 75. And numbers ending with 25 instead are 25, and then 45, and then 65 or 85. And then she interestingly told, okay, so I recollect the mental division strategies that we were discussing in the session 1 and session 2, where we are telling how many tens are there in this number. So therefore, she kind of concluded that in this set, that all the tens are odd tens, meaning an odd number of tens. There are 1 tens or 3 tens or 5 tens or 7 tens. And she was interestingly told that it can be any number, like 4, 4, 3, 5. Even this will end with 75 because it has 443 tens, and this is an odd number of tens. In the other hand, this has an even tens, where it is 20, 2 tens, 4 tens, 6 tens, and 8 tens. And it can be true for any tens, like for example, 4, 4, 4, 5. So this is basically an even number of tens. So this is a very good observation that she has made with the guiding question. Now her next question was why it works so and how can I prove it? And that comes another interesting guiding question to her. So and again, in this case, I just told her that maybe you may need to apply some properties of division, or you can extend the properties of multiplication that you already know to division. In this case, because you have made a conjecture that the odd tens are resulting in the numbers ending with 25, and the even tens are in numbers when repeatedly divided by 2 are ending with 25. So, this actually made her think and come up with an interesting observation of applying distributive property to division. So, this is her work, and this kind of shows how she has made it through with some interesting observations. And she has done the distributive property in this case as so if it is 15 divided by 2, what does actually multiplication property, distributive property of multiplication says? If you have 5 times 3 plus 2, you can do 5 times 3 plus 5 times 2, which is 15 plus 10 is 25. If we took and applied it to the division, 15 divided by 2 is nothing but 10 plus 5 divided by 2. Because we are wondering about tens here always, right? Odd number of tens has a property and even tens has another observation. So she just took 10 divided by 2 and then this can be written as 10 divided by 2 plus 5 divided by 2. which is 5 plus 2.5. So this was her observation that for 15 divided by 2, it is 7.5. And she did the same for 35, 55, 75, 95, etc. And the next one, this is 77.5. So all odd tens are actually ending with 7.75 as the digits. And then with the even tens, which is 25 divided, it is 20 plus 5 by 2, and that is the distributive property says I can do 20 by 2 plus 5 by 2, and 20 by 2 is always a tens, and 5 by 2 is again 2.5, and the answer is 12.5, and the ending digits are 25, right? Here it is 7.5, here it is 2.5. So now she could startlingly say that in odd number of tens, the results, right, is always a 5 base. So if you see 10 divided by 2 is 5, 30 divided by 2 is 15, or 50 divided by 2 is 25, 70 divided by 2 is 35, because they are odd tens. So odd tens divided by 2 is a number ending with 5. And number ending with 5 plus 2.5 is always 7.5 or 7.5 as the ending digit. And the even number of tens like 20, 40, 60, when they are divided by 2, they result only with tens and not fives. So 10 plus 2.5 results in 12.5. And this actually helps her confirm that why odd tens when divided repeatedly with 2 are resulting in 7, 5 as the ending digit, and even tens when repeatedly divided by 2 are ending with 25 as the ending digits. So this explanation she has provided it very nicely here, always comes for even tens, and in this case always comes for odd tens. If you divide any multiple of 5 which has an odd tens, the last digit including the decimals will always be 7, 5. If you keep on dividing the quotient by 2, 7.5 or 7.5 will always be last. If you expand the statement, so she is also proving why it works so. So this is a wonderful conjecture that is made by a grade 6 student just by asking questions, making observations, and looking not for answers but guiding questions which help her kind of verify and then prove why it works and how it works. This is the power of inquiry based learning that happened over the years, which helped them make a this kind of a thinking attitude towards mathematics altogether. Stay tuned and do check out this session of mathematics inquiry learning for simple ideas that you can try out on your own or to your students, which will build young mathematicians. Thank you. Stay tuned.